5.5 applications of adding and subtracting fractions and, of course, mixed numbers. It took Kelly 4 5/6 hours to fly from city A to city B, and it took her another 3 6/7 hours to fly from city B to city C. How long did Kelly fly? Write your answer as a mixed number. That's good to see because sometimes they won't specify if they want it as a mixed number. Which, if they don't, then generally, if they don't specify that they want it as a mixed number or an improper fraction, then it usually does not matter if you write it as your answer as an improper fraction or a mixed number. So keep that in mind. If it doesn't say, then usually I just take the shortest way, which is generally going to be the improper fraction. It saves us a step in the end, right? Instead of having to change improper fractions to mixed numbers at the end, which we've seen from the last couple of lessons, that it's usually the last step there. Now, we see that looks like Kelly's flying from city A to B, and then B to C. So, excuse me, there's two legs to this trip, A to B, then B to C. We want to know how long Kelly was flying. And yes, we do get to assume that she's in an airplane, I guess. But 4 5/6 hours, that's from city A to B, right? So A to B, that's this 4. That's a B, by the way. 4 5/6 hours. Okay. I'll do a better 6 than that. There we go. And then she's going to fly from city B to city C, and that takes 3 6/7 hours. So the total amount of flying would be to add the two trips together, right? Which means we're really looking to add 4 5/6 to 3 6/7. Now, of course, I feel like I'm making this more obvious than it may be for some students. However, it just may take you some time to really think about, well, are we doing some addition and subtraction, right? Because this entire unit has been based on addition and subtraction of fractions and mixed numbers. So, we are using addition on this because we want to know the total amount of time that Kelly was flying. All right, so we're going to take the 4 5/6 and add it to 3 6/7. And the first thing I would do on this one is use some cycle method in order to change these into improper fractions, right? So I start here with 4 5/6. That'd be the cycle method. 4 times 6 first is 24. And then add the 5 numerator to make that 29. So that's going to give us a new fraction, improper fraction, from that mixed number. Now we'll still be adding the two fractions. And I just found the numerator from cycle method is 29. Of course, the denominator stays the same as 6. So it looks like we have 29/6 plus whatever we're going to get from 3 6/7 changed into an improper fraction with our cycle method. So that'd be 3 times 7, which is 21. Add the numerator 6 to get 27. So that gives us a new numerator there of 27. But the denominator is 7. All right. Now, just like we've seen with other examples, at this point we have two fractions that do not have common denominators, which means we're going to need to force the denominators to be the same. If they were already the same, that would have been nice. But yeah, these ones are not. So let's give ourselves a little bit more space. And generally speaking, it seemed like the most common method was to multiply the denominators by the other fraction. So I'm going to use that method, although of course you could make a list, but you're actually going to find that it's going to be the same values that you're going to use. So here's what I mean by that, just to kind of review, is I'm going to look at the 6th denominator of the first fraction and multiply it into the numerator and denominator of the second fraction. So in the denominator, 7 times 6. In the numerator, 27 times 6. So this will change our second fraction. Of course, we're still performing addition between these two values. And I know 7 times 6, the denominator, that would be 42. But I don't know what 27 times 6 is. Let's find out, though. 27 times 6, 6 times 7 is 42. Carry the 4, 6 times 2 is 12, but plus the 4 makes that 16. So 162 40-seconds. That's our second fraction there. And then the 7 denominator of the second fraction, I'm gonna multiply it into the first fraction there. So 6 times 7 and 29 times 7. Of course, 6 times 7 makes 42, which is what we wanted. And that shows that the two denominators match, 42 and 42. I still need to perform that operation of 29 times 7. I should give myself some space. 7 times 9 is 63. Carry the 6. 2 times 7 is 14, but adding the 6 makes that 203. So now we have, as a numerator, 203 40-seconds. And we're ready to add those numerators now. Of course, like we've seen before, adding the numerators, like we're going to be doing, does not change the denominator. So we're going to keep the denominator the same as 42. So we need to take those two values, 203, and add it to 162. But what do we get from that? 203 plus 162. Let's see, 3 plus 2 is 5. 0 plus 6 is 6. 2 plus 1 is 3. So we get 365 from that addition, and that will be our new numerator. Still a denominator 42, by the way. Yeah, that's our new numerator of 365. So 365 40-seconds. So let's see, 42, I know it's divisible by 3 and 2 and 7. That's divisible by 3 and 2 because it's divisible by 6, and then it's just automatically divisible by 7. But 365, let's see. It's not divisible by 3, it's not divisible by 2, right? I added the three numbers. 3 plus 6 is 9. 9 plus 5 is 14, so it's not divisible by 3. It has a 5 in the ones place value, so it's not divisible by 2. What about 7? Is it divisible by 7? It is not. So it appears that is not simplifiable at this point. Now, we'll still check when we change this into a mixed number, right? Because it asked us to change this into a mixed number, so we will. Of course, it won't change the denominator, still denominator 42. But we have to use some long division on this to change the value into a mixed number. So I'm going to take the 365 and, well, divide it by 42. See what we get. Well, 42, let's see, it won't go into 3 or 36, so it looks like we're going to need some multiples of 42. So let's see, 42, 84, I'm just adding 42 to be, I'll show the work for that, by the way. On that. So 42, I'll put a check mark next to my multiples, just like I've been doing. So that'd be 42, our first multiple, add another 42 is 84. And our second multiple, add another 42, which is 126. Third multiple. And remember, we're actually trying to find something now that we looked at the long division that it should be just less than 365. So let's see what we get. 126, let's add another 42. This will be our fourth multiple, right? 6 plus 2 is 8. 2 plus 4 is 6. 168. Add another 42. This will be our fifth multiple. 8 plus 2 is 10. Carry the 1. 1 plus 6 is 7. Add the 4 is 11. Carry that 1. 1 plus 1 is 2. So there's our fifth multiple. We need to go higher, though, so let's add another 42 here. 0 plus 2 is 2. 1 plus 4 is 5. And 2 is just 2. 252. That is our sixth multiple. I know the handwriting got kind of small there. But I need to make sure I have enough spaces. Let's see if I can write a little bit bigger, though. So sixth multiple. Let's find our seventh multiple. Add another 42. 2 plus 2 is 4. 5 plus 4 is 9. 294. There's our seventh multiple. Let's see what the next one is. 42 again. 6, 9, and 4 is 13. Carry the 1. 1 and 2 is 3. 336. Now that's pretty close to the 365. Let's see if we can go one more, right? What is that? Our eighth multiple plus 42 again. 6 plus 2 is 8. 3 plus 4 is 7. 378. So there's our eighth multiple. And yeah, that's just right above 365. So I went a little bit too far on that one. So this is our seventh multiple. Here, the 336. So let's go back up here, and we know that's our seventh multiple. So let's go and start doing some more long division up here. 42, then we'll go into 365 7 times. 7 times 42, we can see there from our list, is 336. We're going to subtract that. which is what, 5 carries, we need to borrow from the 6 to make it 15, minus 6 is 9, 5 minus 3 is 2, 3 minus 3 is 0, so that's our remainder of 29 right there. So we have the quotient and the remainder, that's all we need to make the mixed number. The quotient is 7, so that's our whole value, and the remainder 29, yep, that'll be the numerator. That becomes 7 and 29/42. And again, looking at the fraction to see if it can be simplified, I do not see that it can. 29, I believe, is prime, so it's not divisible, of course, by 3, 2, 6, or 7. Which means that's pretty complete right there. Except one last thing, okay, is this is a word problem, right? And like we've seen with word problems, if we have a word problem like this, no matter what the answer is, we should be looking to label our answers. And this one specifically was talking about hours flown. I guess how long did Kelly fly? How long? We're looking at time, not distance. So yeah, we're going to just label that in hours. And that would be complete right there. Find the perimeter, and we'll write our answer as a mixed number again. That's good to see that so that we know what we're trying to find here. Now, before I perform this operation, because it is perimeter, by the way, which is just the distance around this rectangle, okay? Now, if it was area, like we've seen before in the previous unit, we'd be looking at multiplying these two values, all right? Right here, we're just looking for a perimeter, so that's just addition of all four side lengths. Now, I like to see all four side lengths, but like I said, I'm just going to first change this, these two values into improper fractions, all right? So let's start with the 4 3/4 feet, and then we'll do the 6 5/6. Change it into an improper fraction. So starting with 4 3/4 again, like we've seen before, we use some cycle method to change this into an improper fraction, right? So that'd be 4 times 4 first, which is 16. And then I'd add the numerator of 3 to make that 19. So as improper fraction, 4 3/4, of course, it will keep its denominator of 4, but its numerator now is 19. So it's the same value, just a different look. So that's 4 3/4, but let's do 5 5/6 here. Just right below it. So again, cycle method on this stuff. So I'd start with 6 times 6, which is 36. Then I would add the 5. 5 plus 6 is 11, but carry the 1. 1 plus 3 is 4, 41. So 6 5/6 will remain in 6, but now there's 41 of those 6. All right, so that changes this into these two mixed numbers into improper fractions. So let me go back to the diagram, and I'm just going to fill in these values with values we just found, right? So 4 3/4, still in fourths, but the numerator is 19. 19/4, 6 5/6, still in sixths, but now it's 41 sixths, right? So that means the opposite side as well will match. So that side on the left is 41 sixths, and the side on the bottom is still in fourths, but 19/4. Okay, so I'm showing all four sides. And again, I've said this before with some of the work that we show. For some of you, that may be more work than you would want to see or do. But again, for those of you that may need it, I hope it does help. Okay. Well, the perimeter, like we said before, is just the distance around that rectangle. So we're just going to take these. We're going to take these four fractions. And I'm going to start with the 19/4. See if I can make this work. With some technology, though. There's some 19/4 right there. And I'm going to add the 41 sixths. Okay. Now that's only two of the side lengths, so that means I would have to add again another 19/4 and also another 41 sixths. Okay, so that's showing all four sides, which is the perimeter. Now, could you just add the two sides together and multiply it by 2? Yes, you can, but remember this whole unit is based on addition of these values. And while we should know how to multiply because of the previous unit, I'm still going to be showing just the addition part of this. But you should get the same answer if you added the two sides together and then multiplied it by 2, all right? Well, what do we notice? And I'm focusing just on just these first two, because remember, these other two side lengths right here, they match, right? So I'm going to change these two so that the denominators match, and then we'll change these two accordingly, okay? So 19/4 and 41/6. Well, all right, so we'll do the same thing as we did on that last example. So I'm going to take the 4 denominator here and multiply it into this second fraction there, the 41/6, in the numerator and denominator, right? So I'm going to show the work below it. So 6 times 4 in the denominator, that's 24. That's a good value. We can find that. 41 times 4, though, let's go ahead and show that math over here. In fact, I'll do it kind of below it. 41 times 4. 1 times 4 is 4. 4 times 4 is 16. So 164 24ths from that fraction. And then the 6th denominator, we're going to have to multiply into the numerator and denominator of the other fraction. So that's a denominator still, just like we've seen and we should have expected, to be 24. But the numerator, we're going to have to do some math there, right? That's 19 times 6. 6 times 9 is 54, carry the 5, 4. 6 times 1 is 6, but add the 5 makes that 114. So 114. Okay? Now that was those two fractions. Of course, I've got to go back to the other two fractions and change those. So 19/4 became in orange there, the 114/24. So I'm just going to match it 114/24 there. And then the 41/6, as we can see here, became the 164/24 in green. So that's now 164/24. But again, the main thing here is that we notice that all the denominators match. It doesn't matter how many fractions we're adding together, as long as the denominators match. So we're ready to add all 4 of those values. Make this a little bit longer. So we're still adding with denominator 24. So let's go and put in those 4 values, right? First was the orange 114, then the green 164, then the orange 114, and then the green 164. Now you could add these all at one time, right? But I'm going to add these 2 at a time, really just to make the math a little bit easier, or at least a smaller problem, which to me is easy. Okay, I would take the 114 and add the 164. It's just the first 2 values, and then once I get that sum, I'm going to add the other 114 right there. Now we've shown that in a few different ways, but I'm just going to stack this. Okay, so adding these together, 4 plus 4 is 8. 1 plus 6 is 7. 1 plus 1 is 2. So 278. Then let's add the other 114. So 8 plus 4 is 12. Carry the 1. 1 plus 7 is 8. Plus 1 is 9. 2 plus 1 is 3. 392. And then finally the last 164. And what do we get from that? 2 plus 4 is 6. 9 plus 6 is 15. So we'll carry the 1. 1 plus 3 is 4. Plus 1 is 5. 556. So that's the addition of that fraction, of the numerator of that fraction. So denominator stays the same at 24, but our new numerator now is 556 from this work here that we just did with the addition. So 556/24. I noticed from this one that it's at least divisible by 2. 24 is divisible by 3, but 556 is not. So let's go ahead and simplify these by 2, okay? Of course, you could change it into a mixed number first and simplify, but I'd like to simplify now so that it makes that long division just a little bit easier. So I'm going to say 24. Let's go ahead and divide that by 2, which we know is 12. Hopefully we have that down. 556 divided by 2. We may have to do some long division for that, and that's okay. Let's see if this is enough space for it. 556 divided by 2. See if I can fit this in. It may be kind of small. I apologize for that. But 2 will go into 5 2 times. 2 times 2 is 4. Subtract that out. 5 minus 4 is 1. Drop this 5 to make it 15. 2 goes into 15 7 times. 7 times 2 is 14. Let's subtract that. We get 1 again. Drop the 6 to make that 16. And 2 will go into 16 8 times, exactly. So that's good. That's a 278, just like we thought it was divisible by 2, which I probably should have shown that work there, but it's divisible by 2. And what do we get? 278. I do better 7 than that most of the time. 278 twelfths, okay? Oh, it's divisible by 2 again. Oh, okay, no problem. Let's go ahead and simplify that again, which means that this original value here would have been divisible by 4. And if you saw that, you're welcome to do that if you'd like. You should just get the same answer either way. So I'm going to divide this again by 2. Let's see what that gives us. Okay, so 12 divided by 2, of course, is 6. We should have that down. Let's do that long division again. 278 divided by 2. All right, so 2 goes into 2 once. 1 times 2 is 2. Subtract. That'll zero that out. Drop the 7. 2 goes into 7 3 times. 3 times 2 is 6. Let's subtract that. So that's a 1. Drop the 8 to make that 18. 2 goes in 18 9 times. 139 is our new numerator. So that's simplified to be 139 sixths. And we still haven't changed this into a mixed number. Hopefully that's okay. Because it's still doable, right? 139 sixths. Well, let's see. 6 is divisible by 3. We already found that 556 was not divisible by 3. So 139 is also not divisible by 3. Okay. Well, that means that all we need in the end here is our mixed number instead of this improper fraction. So, setting that up, of course, is equal to the fractional value. The denominator will stay the same as 6, but we got to do that long division. I'll have to do that above. It starts. It gets a little. It may get a little sloppy here just because of. Well, I'm on a presentation thing, but if you're on paper, this may flow a little bit better for your work. So 139 divided by 6. We're just dividing by 6 here. So we shouldn't need to list multiples of 6, the first 9 at least. 6 won't go into 1, but it will go into 13 2 times. 2 times 6 is 12, so I subtract that from 13 to get 1, and I'll drop the 9 to make that 19 now. 6 will go into 19 3 times. 3 times 6 is 18. We'll subtract that from the 19. And this gives us a remainder, it appears, of 1. All right, pretty good. So now we know that the quotient is 23, so that's the whole value in our mixed number. And the remainder of 1 is our numerator. So this is 23 and 1/6. Of course, this is a word problem, right? We were dealing with the shape before. And up there in the top left, it's showing the values were in feet. So we're going to label this one also in feet. 23 and 1/6 feet. Foot? Footses? Something like that. It took Alice 5 5/6 hours to drive to her grandparents' house for Thanksgiving. On the way home, she ran into traffic, and it took her 7 3/8 hours. How much longer did the return trip take? Write our answer as a mixed number. Okay. Now, of course, we can see that her trip to her grandparents took a lot less time than it took her to get home from her grandparents' house. Thanksgiving, right? And, traffic doesn't really matter. It just took her longer one way or the other. That's all we really need to know. How much longer did the return trip take? We're looking for the difference between these two values, right? We're looking for how much more time it took. Now, I'm using all these words to try to help you realize what operation we're going to be using on this game. And just think about this. The two operations we're focusing on in this unit, including this lesson, are addition and subtraction, right? So really, we're only choosing between those two options. So addition or subtraction, well, think about it like this. If we added the two values, it's saying how much longer did the return trip take? It'd be like 13 hours. Well, we can see she didn't even spend 13 hours on the return trip, right? It's only 7 3/8. So since addition doesn't work, which again, it may take some experience and some practice to see that, clearly we're using subtraction here. Now, since we haven't looked at negatives, although we will later on, we should know that we need to take the big number, which in this case is 7 3/8, and then we'll be subtracting the 5 5/6 out. Okay? And we need to know the labels there because when we get our answer, we're going to need to label the answers. Okay? Well, let's go ahead and change these first into improper fractions, right? So I got my subtraction with the two fraction lines, and we'll use some cycle method to change these two values into improper fractions, starting with 7 3/8. So cycle method, 7 times 8 first, that'd be 56. Then add the 3 in the numerator, makes that 9 and 5, 59. So that's 59 numerator with a denominator of 8. 59 eighths, that's pretty good. Now we'll cycle method to 5 and 5/6. So starting with 5 times 6, which is 30, and then add the 5 numerator, which is 35. So that gives us that new numerator of 35 with a denominator of 6. All right, well, that's pretty good. Now, of course, you can still multiply your denominators and get a denominator. You'll get a different one than we're going to get from making the list. And that's okay, though. Remember that your answers either way should be the same, no matter if you use the list or not, or multiply the denominator. So I'm going to make a list of multiples of 8 and 6. Okay? So 8, that'd be, of course, 8 is our first multiple, and 16, and 24, then 32, then 40, and then 48. Now, I'm only going to go to the 6th multiple because I know that I'd multiply by 6 here, and so I shouldn't need to go past the 6th multiple. Same with like 6. If you start with multiples of 6, you shouldn't have to go past 8 because you can just multiply the two together that way. Now, you'll see I went too far on this one, which we'll show. But 6 would have multiples of, well, 6, 12, 18, and then 24. I'm going to stop there because, well, we have our match. 24 in green there and 24 in orange. So the 59/8, let's go and scale that. But we need the denominators to match, right? So that means that they should be 24 by the time we finish, right? Both of them. So I'm going to write these in right now, although you could wait if you'd like. But I'm showing that we're going to force the denominators to be 24 because that was the common multiple between the two. And the 24 is the third multiple of 8, right? 1, 2, 3. So I'd have to multiply the 8 by 3 to get that 24, and we do. But then I'll have to do 59 times 3 as well to get that new numerator. So that's 59 times 3. 9 times 3 is 27. Carry the 2. 3 plus 5 is 15. 3 times 5 is 15, but add the 2 there to make it 17. So 177, 24. There we go. And then 6. Here, this is 24 is the fourth multiple of 6. So I would multiply the 6 by 4 to get this 24 denominator. So we see those match. That's good. That's what we want. But I also need to multiply the 4 in the numerator by 35 right there. 35 times 4. Let's stack this and multiply. 5 times 4 is 20. Carry the 2. 4 times 3 is 12. But add the 2 makes that 14. So 140, 24. All right. Well, we have the denominators the same, which is what we want. Need a little bit more space here. And since the denominators are the same, we can operate strictly in the numerators. So again, I'm going to show this extra step, although not everyone shows or needs it. But I do hope it helps. Now we're going to take 177 and subtract the 140. So let's do the work. I'll do the work below it. 177 minus 140. So what do we get from that? 7 minus 0 is 7. 7 minus 4 is 3. The 1 in the hundreds places cancel out. So it says 37 right here. Okay? So we get a new fraction with the denominator still of 24, but the numerator now is 37. 37/24. Well, let's see. 37 is not divisible by 6, 2, 3, or 8, 4. Any of the values of 24 is divisible by not even 12. And so it looks like this will be the simplified fraction. Now, of course, we need to change this into a mixed number like it says at the bottom there. But not only that, but we're going to need to label our answer, because especially since we're doing this by hand, okay? So I'm going to have a mixed number. And, you know, if you know that you need to label the answer and you know what it is, you could already label it now. We know it's in hours. So I'm just showing that you could label it now if you'd like. The 24 denominator will stay the denominator of the fractional part of the mixed numbers. But we do need to do the long division on this. 37 divided by 24. Well, 24 won't go into 3, but it will go into 37 once. Right, because our multiples of 24 is 24. Here's our first multiple, added another 24, and we've already passed 37 with 48 as the second multiple. So 1 times 24 is 24. When I subtract that, I will have our remainder. 7 minus 4 is 3. 3 minus 2 is 1. 13, looks like. So the quotient is 1. That's our whole value of the mixed number. The remainder, 13, is the numerator of the fraction. And there we go. And we've already labeled it. But yeah, 1 and 13 24th hours. That's about how much longer it took Alice to get home than it did to get to her grandparents' place. A chewy fruit bar recipe calls for 6 1/3 cups of brown sugar and 4 7/8 cups of granulated sugar. How many cups of sugar are in the recipe? But you see there's a second part to this question. How many more cups of brown sugar are there than granulated sugar? And it looks like if we need to, we'll write our answers as mixed numbers. And I believe we do need to for both. So, how many cups of sugar in the recipe? Well, we'll look at both types of sugar. Right? We got, I'll start with the brown sugar. And then we'll add that to the granulated sugar. That will give us a total amount of sugar in the recipe. So let's see, brown sugar. It says, brown sugar, it appears to be 6 1/3 cups of brown sugar. So put that in there for the brown sugar, 6 1/3. The granulated, however, shows at 4 7/8. 4 7/8. Now, to find how much sugar, total sugar, is in this recipe, we need to add the two values. So, of course, just like we've seen before, we're going to need to change these mixed numbers into improper fractions. So that brings up old cycle method. So let's go in cycle method D, starting with the 6 1/3. So I start with 6 times 3 there is 18. Finish off the cycle, add the 1 numerator to make that 19. So that's now 19 thirds as a fraction, an improper fraction. And then 4 7/8, we'll cycle method this one 4 times 8, which is 32. And then add the 7. I had to kind of switch the format on that one. That's 39. So that's a 39/8 as the second fraction. So 19 thirds plus 39/8. Well, we need common denominators here. Okay, well, let's multiply the denominators by each other, which, yeah, let's fact that actually ends up being the best method for this particular case. So whatever we get on this, we're going to get two new fractions, although it will not change the value. It's just going to change the way they look. So I'm going to take the 3 and multiply it into the numerator and denominator of the second fraction. So 8 times 3 in the denominator, that's 24. And then we got to do 39 times 3. See if I can squeeze that in somewhere. 39 times 3. 3 times 9 is 7. Carry the 2. 3 times 3 is 9. Plus 2 is 117. 11, really. 117. I'll find the value there. And then the 8 denominator here, I'm going to multiply that by the denominator and numerator of that second fraction. 3 times 8 is 24. So we get matching denominators just like we want and need in order to add these fractions. But 19 times 8, what do we get from there? 19 times 8, that'd be 72. 9 times 8, 8 times 7, okay, that's 7 there. 8 times 1 is 8, but plus the 7 is 15. So 152. 24. All right, that's pretty good. Now that we have common denominators, we can add the two numerators. We'll keep the denominator the same still, like we've seen. So we're going to take the 152 and add the 117. What do we get from that? 152 plus 117. 2 plus 7 is 9. 5 plus 1 is 6. 1 plus 1 is 2. 269. For our new fraction, still is in 24ths. But we have a new numerator at 269. 269 24ths. So let's see if this can be simplified. 24 is divisible by 2 and 3. Well, 269 is not divisible by 2. Is it divisible by 3? No. If you added those values together, you get 17. That's not divisible by 3. So it's not divisible by 8 or 12 or 6 or any of those other ones. Okay, so it looks like we're looking at a simplified improper fraction at this point. Okay, so the answer though needs to be as a mixed number, as we see on the bottom. So we got to do some long division on this in order to change it into a mixed number. Okay, and just like we've done before, we'll check the mixed numbers fraction to see if it can be simplified in the end. Okay, so I know the denominator is 24 in our mixed number. Just got to figure out the whole value and the numerator of the fraction. So we're going to take 269. You have to do the work above it. I kind of ran out of space there. 269. And divide this by 24. So let's look at the multiples of 24 again. I know we've seen them already. Seems like 24, 48. Again. 48, 12, and 6, 7, like that. Oh, 72. Plus another 24, 6, 96. Another 4 there, 20, 120. I felt like I did some wrong there, but I think we're good. Add another 24, so that'd be 144. Add another 24, 2, 6, 168. Another 24, 12, 7, 192. Add another 24. What did we get there? I think I've gone too far on this. It's okay if I did. I think it'd be 216. Yeah, it looks like I've gone too far because 24 will not go into 2, but it will go into 26. Yeah, just the one time right there. Well, 1 times 24 is 24. So when I subtract that, I get 6 minus 4 is 2. We'll drop the 9. That's just 29. Oh, I went way too far on my multiples there. I probably should have stopped at 120 anyways, but 24 will go into 29 another 1 time. 1 times 24 is, well, 24. When I subtract that, I'll have a remainder of 5, it looks like. So the quotient there is 11. Sorry, that's kind of squished in there, but 11. And the remainder of 5, that's our numerator of the fraction. All we got to do now is label our answer. And this was in how many cups of sugar? So yeah, we're looking at cups still of sugar. What the heck? Let's put cups right there. And that would be the total amount of sugar, cups of sugar, in this recipe. The second part here, how many more cups of brown sugar are there than granulated sugar? And yeah, we should be able to tell, even without changing these into mixed numbers or anything, that we are looking at more cups of brown sugar here, the 6 1/3, right? And then the granulated sugar is just less than that. That's nothing we can do about that. Now, the good news here is that since we're looking at more cups of brown sugar, this would be the difference between the two, which means we'd have to take the 6 1/3 cups of brown sugar, and we'd have to subtract from that 4 7/8 cups of granulated sugar. Okay. Now, the good news about problems like this that have multiple parts in the same thing, when we're dealing with the same values anyways, is that we've already changed these not only into improper fractions, but into improper fractions that match the denominators, right, where we use the 24 over here. So I can see the 6 1/3 became the 19 thirds, which eventually became the 152 24ths. So I'm just going to rewrite that right now as 152/24. So that's the 6 1/3. And then the 4 7/8, that was changed into 39/8, which was then changed into 117/24. Again, even though it was changed, we changed the way it looked. It did not change the value of these. And I put addition between that. I should have put subtraction. Sorry about that. I feel like that was a lucky catch on my part, but I think we would have known it once we got to the operation. So we just changed the two mixed numbers into improper fractions, which we already knew. And why are we using 24 as the denominator? Well, we already had it, and we're just using a different operation here instead of addition. We're now looking at subtraction, right? So we're going to look at 24ths here with subtraction. Of course, the first numerator there is 152. Go and write that in, 152. And the second numerator, 117. Okay, so now instead of adding these like we did in the previous problem, we're going to be subtracting these two values. So 152 minus 117. Let's see what we get from that. Minus. Let's see, 2 minus 7, we'll have to borrow from the 5 to make that 12. 12 minus 7 is 5. 4 minus 1 is 3, and then 1 minus 1 is, well, 0. So this ends up being 35/24. 35/24. Well, 35 is divisible by 5 and 7. 24 is not divisible by either one of those. So it looks like we're just going to need to change this into a mixed number. And yes, we're still dealing in cups. So I'll put that label in there if I can squeeze it in. I feel like that works. But the denominator will stay the same, right, as 24. So we just got to do some long division in order to find our mixed number values on this. So 35 divided by 24. Of course, we're only looking at one multiple here. 24 won't go into 3, but it will go into 35, like we said there. One time. 1 times 24 is 24. When I subtract that, I get 5 minus 4 is 1. 3 minus 2. In fact, I'll use a different color here, is 1. So that's our remainder. So the quotient is 1. That's the whole value of the mixed number. The remainder is 11. So that's our numerator of the mixed number. And that there would be considered complete. Jenny measured 1/3 cup of flour and 1/4 cup of flour. How many total cups of flour did Jenny measure? Give your answer in reduced terms. So it looks like if we need the answer as a mixed number, that we will. But if not, we'll just keep it as a simplified fraction, whatever it is. Okay. So how many total cups of flour did Jenny measure? Well, the first set right here shows it was a 1/3 cup, right? So it's a 1/3. The second set, or the second measurement there was 1/4 cup. Now, how many total cups of flour means we need to add the two scoops that you put in. I'm going to say it's 2 scoops. I'm trying to think of how that should be worded, but it's really skipping my mind on this one. So the most common method that you guys seem to like is multiplying the denominators. That's what I'm going to do. But you should also know that 12 is the least common multiple between these either way. All right. So we're going to change these because we have to. We have to change the denominator so they match. So I'm going to take the 3 denominator and multiply it into the numerator and the denominator of that second fraction. So 1/4 then becomes 1 times 3 is 3 in the numerator. 4 times 3 in the denominator is 12. 1/4 becomes 3/12. But I take the 4 in the second denominator and multiply it in the numerator and denominator of the first fraction. So that changes 1/3 into 1 times 4 is 4 in the numerator. 3 times 4 is 12 in the denominator. And now we have denominators that match at 12. We just need to add the two numerators together, 4 and 3. I don't feel like I color-coded this one very well, but it's all right. It'll still work out. 12, right? 4 plus 3, we shouldn't need to stack that. We should just know it's 7. So I have 7/12. Of course, this is already a proper fraction, and 7 is prime. 12 is not divisible by 7. So that's pretty much as far as we can take that one. We just need to label this. How many total cups of flour did Jenny use? 7/12 cups. You can say a flower if you'd like, but that's more work than I want to do. Alright, so we just made up these values, and I guess I forgot to put labels on them. I'm going to make this in meters today on this one. So 2 3/5 meters, 4 3/10 meters, and 2/3 meters. And we want to find the perimeter of this triangle. Of course, we'll make our answer in as a mixed number in the end. I know it doesn't say it on this one, but we're going to assume that it would. Okay, just like we saw in the problem earlier in this lesson. So let's take all three values, and we're going to need to add these together because that's what perimeter is, just adding the values outside of the shape. And we're just looking at a triangle here. So three different measurements on this one. We got 2 3/5, and we have 4 3/10, and also 2/3. And yes, we're just adding these together. Now, for me, the 2/3, of course, is just a proper fraction. That's not a problem. However, the 2 3/5 and the 4 3/10 need to be changed into improper fractions. I should have given myself more space. So I'm gonna change these into improper fractions 1, 2, and yes, we're still adding these together. And then our final fraction there, the 2/3, is just going to stay 2/3. Right, but I need to scale these other ones, or we're not scale, but cycle method, change these into improper fractions. Of course, denominators will stay the same, so I'm going to fill those in right now. So the first fraction has the denominator 5, the second mixed number has the denominator 10. So cycle method now. This will give us a new numerator for 2 3/5. So that would be 2 times 5, which is 10. Then add the numerator 3, which is 13. So that's our first numerator of 13. 13/5. And then the second numerator will be 4 times 10. Right? Just using cycle method, that's 40. And then add the numerator 3 to make that new numerator 43. So 43/10. So I have 13/5 plus 43/10 plus 2/3. And I probably should have given myself more space. Okay, now what I'm going to do on this next step, and I'm going to be showing all the work on this, but I'm going to just split this up. Okay, what I mean by that is I'm not going to work with the 2/3 yet. Okay, I'm only going to be working right now with the 13/5 and the 43/10, which means we're still going to end up adding the 2/3, but I'm going to add the 13/5 and 43/10 in order to find a new value that I'm going to be adding to the 2/3 right there. Okay, so I'm just simplifying this from 3 different terms into 2 different terms. Okay, in fact, just the 2 terms into this one right here. I don't know what it is, so that's why I'm keeping this blank. Okay, so I'm going to just focus on the 13/5 plus the 43/10. So 13/5 plus 43/10. What I need is common denominators, and I see that 10 is a multiple of 5. So instead of multiplying the 2 denominators by the other fractions, I'm just going to kind of simplify this right now and multiply the 5 by 2 and the 13 by 2 as well. That's just going to make things just a slight bit easier for us. Of course, the 43/10 stays the same, 43/10. But we see from the first fraction, 13 times 2 and 5 times 2 in the denominator. 5 times 2 is 10. We can show 13 times 2 here is stacked. 3 times 2 is 6. 2 times 1 is 2, so that's 26/10. And now that those denominators match, we can show this as one fraction. We're going to add the 2 numerators, 26 and 43. So what do we get from that? 26 plus 43. That appears to be 6 plus 3 is 9, 2 plus 4 is 6. 69 tenths is what we get out of that. 69 tenths. So we simplified these two, 13/5 and 43/10. After we add them, we got 69 tenths. So that is the value that I'm going to be adding to the 2/3 there. Now once again, we see that the denominators do not match. Okay, I mean, we kind of did with the 5 and 10, but now we got to do it again with 3 and 10. So once again, I'm going to be multiplying it. Well, not again on this one, but I'm going to multiply the two denominators by each other. So I'm going to take the 10 denominator here. I'm going to multiply it by the 2 and 3, the numerator and denominator of that second fraction. Now this is going to change the way that fraction looks. Of course, it's not going to change its value, right? So I have a denominator, 3 times 10 is 30, and in the numerator, 2 times 10 is 20. 20 30ths. But then I've got to take the 3 denominator of the second fraction and multiply it by the numerator and denominator of the second fraction. Now in the denominator, 3 times 10, we should already know that it's going to be 30, right? Because we need the denominators to match before we add. But we're going to have to do some calculations with 69 times 3. So 3 times 9 is 27. Carry the 2. 3 times 6 is 18, but add the 2 makes that 20. So 207 30ths. Well, from here we have the matching denominators of 30. So we just need to add the two numerators, 207 and 20. And whatever we get from this addition will be our new denominator. I don't have enough space. So let's go ahead and give ourselves some space there. Alright, so 207 plus 20. And yeah, I know some people can do that in their head. That's okay if you can, but if you can't, then hopefully this helps. So 227, that's our new numerator. The denominator stays the same as 30. So 227 30ths. 227, it's not divisible by 3. I mean, it's close, but not quite there. 30 is divisible by 3. It's also divisible by 5, 6, and 10, but 227 is not. So, looks like that's simplified. We just got to actually do the division on these, because we need to change this back into a mixed number. So, let's do the long division on this. 227 divided by 30, and this should give us our mixed number. Of course, we were dealing in meters, right? So I'll label that now. And our denominator should not change. It should still be in 30ths. Just got to find the whole value and the numerator of the mixed number. Oh, it looks like I'm going to need multiples of 30 as well. So 30, and again, everything's just going to end in 0. So I'm just adding 3 to 3. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12 with a 0, plus 3 is 15 with a 0, plus 3 is 18 with a 0, plus 30 is another 210, and then another 30, 240. And yeah, I think we're going to need all of those, because 30 will not go into 2. It won't go into 22 either, but it will go into 227. Yep, we need the 210 right there. That is the 7th multiple of 30. So 7 times 30 is 210. When I subtract that, I will have our remainder, which is the numerator of the fraction. 7 minus 0 is 7. 2 minus 1 is 1. So a remainder of 17, a quotient of 7. So 7 is the whole value. The remainder of 17 is the numerator of the fraction. 7 and 17 30ths. Just a quick check. Yeah, I don't see that this fraction can be simplified either. So it looks like we reached the end of this problem. 7 and 17 30ths is just the final answer on this one. That would be the perimeter around our original triangle up here. Now, I mean, was that a little bit of work? Yeah, it was. I don't know that it was even necessarily more work than the rectangular example we did earlier, but again, more work doesn't necessarily mean more difficult work. It's just extra work, that's all.